You see, one thing I don't like much in many articles or in some press releases and even in some description of batteries is the fact that often battery type is described as LCO battery, for example, or LFP battery or NMC battery, just supposing that all battery parameters, characteristics are defined by only one material, by positive electrode material, but it's not so. Any characteristic, capacity, cyclability, price, safety are defined by both electrode material as positive, so negative electrode material, as cathode, so anode. And of course, carbon-based material as dominant and the most popular and used almost in all batteries, but almost doesn't mean in all, because lithium titanate as alternative for carbon-based material is also rather widely used. You can find it in buses, in other applications for grids, for example, for battery storage for renewables. And let's consider, first of all, why lithium titanate is a kind of, not so popular as carbon-based materials. And we're not considering, for example, big two materials as a big three for cathodes. In fact, when we compare capacity of three, for example, types of negative electrode material, lithium metal, carbon-based material, graphite, for example, and lithium titanate has the least specific capacity. For example, if we not consider lithium metal with its record high capacity, theoretical capacity, and consider carbon or graphite, more correctly to say, with capacity about 375 ampere hour per kilogram, for lithium titanate we can speak only about 175 ampere hour per kilogram. And it's not the only drawback, capacity, it also has higher potential versus lithium metal. So lithium metal has a zero, it's a kind of ground, it's a basic level of our measurement. Carbon has also rather low potential, and lithium titanate has potential about 1.5 or more correctly to say 1.55 volts compared with lithium metal. Why it's not so good? Again, just to the fact that the voltage of the electrochemical cell is defined by the difference between potential. And for lithium titanate, for example, voltage for NMC battery with NMC positive electrode materials results in lower voltage than NMC cathode with lithium metal or carbon-based materials. So it's a kind of strong drawback of lithium titanates. Of course, if we will keep in mind that lithium titanate is rather dense, and if we measure its capacity not specific but volumetric, it became a little bit higher and comparable, rather comparable with carbon-based material, with graphite, and of course still far away from lithium metal. Nevertheless, it still has rather, high voltage. But when we talk about lithium titanate and its advantages, why it's used, why it's widely used in real life, we can mention, first of all, extremely high cyclability. In fact, it's not so easy to define how large is cyclability, because it's in general, it's not to say it's very high. Because, for example, it's a huge problem how to measure cyclability at rather low rates. For example, consider 1C rate. It's not low rate, it's rather a high rate. It's charging or discharging within 1 hour. What does it mean? It means the full charge and discharge of such a cell at such rate as 1C rate result in 2 hours of measurement just for one cycle. Per day we can measure 12 cycles of charge-discharge. Per year we can measure about 4,000 cycles. So 4,000 cycles just for 1 year, and how to measure, for example, 40,000 cycles, it's 10 years, it's very hard to do. So for lithium titanate, we can say that proper made lithium titanate can boast of incredibly high cyclability and extremely high cyclability. Also, it can be used for high power application, and it's less, it's more safe, it's less toxic, and use less more abundant materials. Talking about toxicity and presence of abundant materials, it's just the property of titanium as one of the key elements used for production of lithium titanate. But when we talk about cyclability and using for high rates of charge-discharge for high power application, such unique properties are defined by two main properties of lithium titanate. First one, zero strain property of lithium titanate. Lithium titanate is often named as zero strain material. It means that during lithiation and delithiation, so inserting and extracting lithium ions, it almost doesn't change its volumes, it stays the same. So you have no mechanical stresses, you have no losing the conductive contact and so on and so forth. So it's a very important property. And the second property is almost absence of so-called safe formation. Of course, some interface anyway is formed during the interaction of solid phase of active material and liquid phase of electrolyte. But nevertheless, in this case, the drawback of material, its high voltage, became disadvantageous because when we operates in low voltage, it results some more intensive decomposition of electrolyte, and this decomposition can be irreversible. It results in formation of interface of such decomposition, results in formation of solid electrolyte interface formation. And in case of lithium titanate, the voltage is higher. Of course, stored energy became lower, but nevertheless, it's more comfortable if we can for electrolyte, and decomposition of electrolyte is much less pronounced, and we can use this battery with lithium titanate more and more cycles with high rates. So it's one of the properties.